Hi, folks. We're going to take a look at number 9 from the Unit 7 review. So here it says that Richie walked 15 meters diagonally across a rectangular field. Okay, so let me start, even before I read the rest of the question, let me set up a diagram here. All right, so it doesn't matter which diagonal. So let's say I take this diagonal, walked across, and it looks like that is 15 meters. Okay, let's see what else is happening. He then returned to a starting point by walking along the outside of the field. Okay, so I don't think it matters whether he goes this way or that way. Since it's a rectangle, will make a difference. So walks this way and then back to where he started. All right. And it says that the total distance walked was 36 meters. What are the dimensions of the field? Okay, so what we're looking for is the dimensions of the field. In other words, the length and the width. Okay, so I know that this is what I'm looking to determine. And one of the things that I'm told is that the total distance walked is 36 meters. So I can write length plus width plus 15 is equal to 36. But of course, this is not enough to solve for L and W because I've got two variables. So I'm going to need some other relationship um, that'll help me write a second equation. All right. And I hope that as you look at the diagram, you see that another relationship has presented itself because the walk that Richie took forms a right angle triangle. All right, so there's another relationship beyond the perimeter that we have. We have that the sum of the squares of these two sides is equal to the square of 15. Okay, so that's going to be the second equation that we can write in L and W. So we have that L squared plus W squared is equal to 15 squared. Again, two variables. So the question is, which one of these should I use to isolate a variable? And then once I do that, I'm going to input that into the other equation. Well, hopefully it's pretty clear that this is the one which is easier to isolate, because if I try to isolate a variable in this equation, I'm going to have to take a square root, which I definitely don't want to. So here I'll isolate W. Okay, won't make a difference. So 36 minus 15 is 21. Okay, and then I'm going to bring the L to the other side, minus L. So now I'm going to take this and input it into my equation. So L squared plus, wherever I see W, I'm going to replace it by 21 minus L. Okay, and 15 squared is 225. And when you look at this here, you realize that it's just a quadratic equation. So I'm just going to have to simplify, put it in the correct form, and then I'll likely use the quadratic formula. All right, so let's do this here. So L squared plus, this is the square of a binomial. So I'll use my little trick here, square the first. So 221 squared is 441 plus twice the product of first and last. So 21 times 2 is 42. So minus 42L and then plus L squared equals 225. All right, so now bring together the L squareds, 2L squared. All right, minus 42L. And here, just to be sure that I don't make any silly mistakes, let's use a calculator here. So what do we have? We have 441 minus 225. Okay, 216. So that's going to be plus 216 equals 0. Now here, actually, to make my life simpler, not that this is necessary if I'm going to use a quadratic formula, but I can divide both sides of the equation by 2. It'll make things a little easier here. So here I have L squared minus, that'll be divided by 2, so 21L, and then plus 216 divided by 2 is 108. Okay, so I could certainly use the quadratic formula here, but I actually noticed something. 108 is 9 times 12. And 9 and 12 add up to 21. So I can actually factor this. So this is one of these few scenarios where we have an application question where we can factor. So I might as well take the opportunity to do that. Okay, so L and L. Okay, and it has to multiply to positive 108, but add up to negative 21. So that's going to be minus 9 minus 12. And so here, L minus 9 is 0, or L minus 12 is 0. So L is equal to 9, or L is equal to 12. So based on what I'm seeing here, it's possible that we have two different rectangles that can produce the same values. So before I do that, I'm going to take a look and see what I'm actually looking for. So I'm looking for the dimensions of the field. So L and W. Okay, so let's start with option number one. If L is equal to 9, well, I can now resubstitute this here to find W. So W is 21 minus 9, so that's in meters. So it's going to be 12 meters. And then in option number two, if L is equal to 12, well, I think I see what's going to happen here. 21 minus 12, I end up getting essentially the same rectangle. So whether it's 12 by 9 or 9 by 12, it's essentially the same rectangle. So I'm going to finish off by saying the dimensions are 9 meters by 12 meters. Okay, so there's my answer. And just to do a quick recap here, it's really the diagram that helped me to figure out this problem, because I could see that I was given the perimeter that was walked. So that was one equation. And then I noticed that uh, the shape that was walked was a right angle triangle, hence I could use Pythagoras. And then from there, I was able to do a substitution to get a quadratic equation. Okay, that's it for this one.